Okay, welcome everybody again. Thank you for taking the quiz. I hope you enjoyed it. Last time we wrote this code to just try programming the microcontroller by sending the machine code to the microcontroller. We had a problem with one LED that didn't work. Debugging showed that in simulation it works. Sending it to port C also works. Changing which two LEDs on and which are off. So I changed the CC to 33 hex and also works. So no problem. We can move to the next topic. Okay, so we talked about the programmers. The programmers had one of the, how programmers look. This is another kind of programmer. This is our board, and it has an onboard programmer. Okay, this is the older version of the board, but I showed you live our board. This is an open source programmer I used to use in the old days. Oh yeah, I just remember something. This is the machine code. You can view it in the program. Let me just show it to you. So this is our program. I want to build it. Again, see, I changed this to 33. Okay, so I want to build the program, build all successful. Okay, so looks like type. I want to program it. So I go to this programmer. See, I load my hex file where I stored it, class demo2 leds.hex, open it. I set the oscillator type high speed and disable the watchdog timer. Then I write it, okay? But before I write it, I want to show you something. You can see the code. See this button code? You can see the machine code generated. This is what's going to be sent to the program memory on the microcontroller. What does it show? It shows address 000 with instruction machine code 2820. This is what? This is the first instruction at address 0, go to main. Main is at 20 hex. So I'm telling him go to 20 hex. And if you go back to the machine code, 28 is the go-to. Okay, we did it. I'm not going to repeat it again. However, this is 28 go to address 20 hex. Then address 1 is empty, address 2 is empty, 3, 4, 5, until you get to 20 hex. 20 hex is the first instruction here, 1683. What is 1683? 1683 is the bit set F status register, which means address 3, bit number 5. Okay, and we learned how to get the machine code if we know the instruction from the instruction set table. Okay, the instruction set table here. Where's the instruction set? So you go to the instruction set, and then okay, bit set F. It starts with 0101, then 3B, which is the bit number for our case 101, a little bit 5, right? And address 3 00000011. Convert it to hex, you'll get that number. Okay. So as a scenario, if I give you something like this, can you give me the original code, assembly code that was written? Hey guys, NIS people, security guys.
Yes, you can.
Reverse engineering. Does this make sense to you? If this is a way that you guys as hardware engineers or computer engineers who have the knowledge in hardware and low level, things that you guys can work on for ethical purposes, okay, in hacking or cracking hardware, okay. Um, just so if I give you this, something like this, you can reverse it and know what is the original code. Okay. Well, I can program it now by just hitting right. Then it is programming. I'm going to switch the camera to the board so you can see the board. The board is here. Well, شايفين?
Yes.
See the LEDs? Yeah. So this is 00113.
الكاميرا ما تغيرت.
الكاميرا ما علبت.
My camera. Okay, I'm gonna stop sharing. غيرت. Okay, بس
لازم.
how about now?
Yes. Okay.
Okay. 0011 0011. This is the 33, right? Okay. Back to our stuff. So I'm done with this part. Okay, so we know the programmers, we know how to see the machine code when you send it before you send it to the program memory, and we wrote a simple program. Last concept I want to cover here is the indirect addressing mode and the FSR register. If you remember in the let me talk about the 16F84A controller. 16F4. Okay. This is the data memory, the RAM. Right? Where is my pen? Oh. شايفينها؟ This is the RAM. There is address 0 in the data, the file registers or RAM, whatever you want to call it, file registers or RAM. See address 0 here. Well, address 0 here. What is it called? Indirect address. Okay. And there is another register here called FSR. FSR is short for file select register. Sorry? Abdullah, you want to say anything? Okay. طيب. See file select register, so we're going to work with these two registers. And again, if I go back to the architecture of the microcontroller here, here's what I'm talking about. See this file select register? So when we talked about addressing a memory location in the RAM, this is the RAM, the file registers, and it's two banks, bank 0 and bank 1, has 68 locations. Each location is 8-bit, right? We set the address of the location we want to select, either to read or to write in, or I don't know what. Either comes from the instruction itself. So you say, move letter clear F, right? So you say clear F and 0x03, for example. Okay, this is the address. I clear the memory location F here with address 3. Where did this 3 come from? It came from directly from the instruction. It's part of the instruction. Okay. Now this is a direct addressing mode. There is another addressing mode called indirect addressing mode, where the address comes from the FSR, which means you say clear FSR, okay? So it's not gonna go clear, well, I'm gonna show us. You don't say clear FSR. Well, you can say clear FSR. there is FSR and INDF. Okay, INDF. These two complement each other to directly access this the memory locations here in a different way than just providing a static address in the instruction. Okay, you can make the address like a pointer or a variable you can change. Many benefits, and I'll give an example. Okay.
دكتور بس ممكن بالدايركت ادرسنج ليش 5 بيتس؟
Well, this is how the hardware is designed. Yani, there are only 5 bytes, 5 lines here. The instruction only, yani, this is the design. Why is this 13-bit? Why is this 14? This is how they designed it.
تمام.
Okay. Okay. And with 5 bits, how many memory locations you can address?
32.
2 to the 5.
Yeah, 32.
Right. 2 to the 5.
32.
32. Yeah.
مش 2 to the 6 minus 1 أو شيء زي هيك.
لا 2 to the 5 بس minus 1 هو starting where, right? So 2 to the 5. 2 to the 5
plus 2 to the 4.
What is 2 to the 5? 32, right? 32 addresses. The addresses is from 0 to 31. Okay. Okay. طيب. So I'm gonna use two registers here. One is called FSR and one called INDF. Okay. Where is the data memory again? Oh man, I lost it. Yeah, here. Okay, so I'm gonna use address 0, the INDF, and the FSR address 4 to address memory locations. So let's give an example. So we address 0x00 is a register called INDF, and address 0x04 is a register called FSR. Okay, and to make it easier, I hope I have the memory here. Let me copy it again. Let me copy this again. Okay. Well, طيب ماشي هيك.
So use snipping tool.
Well, I was gonna do something different, بس ماشي snipping. Okay, and your name, Jawad, got in here. Okay, so we're talking about these two memory locations and 4 FSR. So imagine we're at the 77A microcontroller and we have 100 memory locations here. Okay, imagine it's we have more locations, or 10 if you want, or these 60 locations, 60 locations starting at address 0x0c. Okay. Down to 0x0d, 0x0e, 0x0f, 0x10, etc. until we get to a location from here to here, 100 locations. Okay. Let's assume that these 100 locations, this is an address, right? we want to go do something in them. مثلا, go increment every number inside each location by 1. مثال, or go make them zeros, or go write any number in all of them. You want to repeat something 100 times. The way we can do it using the tools we have right now is just to say go clear. So we want to clear the 100 locations, okay? Starting at 0, starting here. So we say clear F 0x 0c, then clear F 0x 0d, and we repeat this 100 times, right? Is there any other way we can do it? Anybody aware of any other way we can do it?
Loop.
Loop. طيب, tell me how I'm gonna do the loop.
بنقدر مثلا يعني هل هو قصدك دكتور انه كيف بنسوي اللوب يعني؟
Yes. يعني افرض اوكي عندي مكان هون after ال 100 locations هاي او let's say 60 locations لانه عندي 68, right? 60 locations. And at address 61 here, I have a counter 60. Okay, so I can count decimal.
هلا
How am I gonna do it?
نقدر مثلا بنحط ليبل.
Where?
هلا وين؟
Remember about remember the truth about labels. We use the label here. We use the label here. Okay, these labels, when you generate the machine code, will not exist. Okay, when we generate the machine code, you don't see go to main. You see go to address 20. See. You don't see go to here. You see go to 25. Labels are labels for the assembler, but when this is at the program memory of the controller, it's only numbers or registers. So you cannot rely on labels. Okay, so you cannot say a memory location is a label. Clear F, then say memory, but then increment memory. This is not doable. The only way to do it is using the two registers FSR and INDF. تمام? But let me show you the difference between them. FSR is at address 04, right? So if I say clear FSR, what's going to happen?
0.
It's going to go to memory location address 0x04 and clear it. Write a 0 in it. يعني هون راح يصير 0. Okay? But if you say clear F INDF, guys, am I recording? I think
Yes.
Yes.
Yes, doctor.
Am I?
Yes.
yeah.
طالعين.
Okay. Clear F INDF. What's going to happen? It will go. This is an indication that this is an indirect addressing. So it's not going to go clear what's in address 0. Okay. This will mean go take the number in FSR and treat it as an address. So FSR, for example, originally had 0x0d. Okay. When I wrote clear FSR, it's going to go to address 04 and clear it. But when I say clear F INDF, it will go check FSR. What is it? What's in it? 0x0d. It will go to 0x0d and clear it. Okay? Write a 0 in it. This is the meaning of INDF. When you use the INDF memory location, it will not go at access address 0. It will know that the address we want to access is inside the memory location called FSR. You go get it from here. Tamam? So if we want to do our example here in of clearing 60 memory locations starting at address 0x0c, what would we do? First, we need to initialize a counter at a memory location. Let's call it, give it a temporary, a label called counter. Okay. But you need to, after 60, so what is 0c plus 60? This will be the last location. The one after it, you give it to the counter. Okay, so we say we need the counter. Well, the counter can be, if we go check the instructions, where are the instructions? Here are the instructions. We need to decrement something and skip F0, so it has to be a memory location, right? Yeah, let it be the counter. So we can say move lateral to W 60 decimal. Then we can say move W to F to the memory location that I know the address here, or use the label called counter. Okay, let's assume it is address, I don't know, 0x, what is 60 plus 0c? Let's do it real quick. In hex, well, 60 in 60 locations in decimal will be 3c in hex. Okay, 3c in hex. So so I'm gonna add c plus 3c. Okay, it's gonna be 48 hex, right? 48 hex. So at address 48 hex, we can write our counter. So instead of this, you can say 0x48, whatever. Okay, a label will do it and the assembler will calculate it for you. And when you make sure that the address is there, there's a memory location. Okay, now we have a counter with a value 60 decimal in it, and we want to repeat an operation 60 times. First, I want a pointer to point at the first memory location. The pointer is, in this case, the FSR. Okay, so I need to write 0x0c in FSR here. Okay, so I say move lateral. Well, you know what? I should do this before. Let me initialize the pointers before. Well, it doesn't matter. Doesn't matter. So move So what we did here, we initialized counter. Then we move lateral to W 0x0c, and then we move move W to F, the 0x0c, FSR, or if you want to say 0x04 here FSR. So if you wrote FSR equates 0x04, you can just directly say FSR. Okay. So what we did here is we make FSR point to the first memory location. which is the first memory location we want to clear. Okay? Then what we do, we say clear F. What do we do? Right.
0x00 هلا.
Exactly. INDF. INDF equates 0x00. So we said access the memory address 0. Address 0 means, oh, go get the address from FSR. Okay? So clear F, INDF. This will clear address 0C. Okay? So if we write it here, this will go 0x0C and write a 0 in it. Now we want the pointer FSR to increment and point here, right? So we say increment FSR. Now FSR points to the second memory location, right? But we did it once. So the counter, our counter that counts 60, it's 59 times left, right? So we decrement the counter, and if it's not 0, we keep doing this again and again 60 times. If it's 0, we're done. So we say decrement F and skip F0. What do we decrement? The counter. Okay. Counter also is here. Counter equates, what was the address? 48 hex, right? We calculated it. 0x48 hex. Okay, decrement F and skip F0, counter. Now, when this is 0, and when we're done with the 60 times, the next instruction is going to be skipped. If it's not skipped, then we're not done yet. So we say go to again, for example. And again will be what? Increment, clear the memory location. And increment the counter. After this is done 60 times, right? And it's 0, the go-to is gonna skip, and we say, we continue our code. Continue doing whatever you want to do. Okay, is it clear? What is
ممكن سؤال
INDF?
بس.
تفضل.
احنا الكاونتر وين سيبنا الكاونتر؟
سيبناه ميموري لوكيشن هون تحت بعد ال 60 لوكيشن هذول لوكيشن فاضي
بعد
48
اوكي
بعد ليش حسبنا 60 بلس 0 سي
تمام
48 هذا فاضي ما فيه شيء حطينا فيه كاونتر
اوكي تمام
في الداتا ميموري. Clear, guys? Okay, no questions means we're good. So we are good. I think we're done with this chapter 4. So adding more examples from the book and more explanation from the data sheet about how it works, and what I just wrote is a good example. Like demo to program. Oh, we did this last time, so. And we're good. Chapter 4 is done. Okay. It's done on time. It's 10:50. So next time we start with chapter 5. See what we did? Chapter 5 is going to be a real quick one. We did the loop right now, right? We did a loop. We wrote good programs. Chapter 5, it's about building assembler programs. Designing, first thing is about visualizing how you design an embedded software through flowcharts, state diagrams, etc. Then you start with working with conditioning, branching, conditional branching, bit test, and loops, and calculating time. And we already did some of these. Okay, subroutines, which is not a big deal. We're going to deal with it. Delays, write a few examples and logical lookup tables. It's more deeper into software, assembly software. Okay, then we'll start C. So chapter 5, my anticipation is going to move real quick. It's all about a few concepts and practicing writing good, more complicated pieces of code. Then we move to the next chapter 6, and there we go to the micro C and start writing in C. We do the first demo, then Mohandas Jawad will start with you using the simulator. So whatever I do here on my on my board, you go do it in the simulator. Okay, so I'm gonna end we're gonna talk about the office hour, Mohandas Jawad. Let me end the session, and we continue chatting. Okay, just give me a second. So next time we start with chapter 5. Thank you. Thank you very much.
يعطيك العافية.